Olympus Mons, located on Mars, is not only the tallest mountain in the solar system but also the most imposing volcano ever discovered. Standing at a staggering 22 kilometers in height, it far surpasses any mountain on Earth. To put it into perspective, the entire country of France could fit within its width, while its crater spans an area comparable to Sicily. These impressive facts are often repeated in various forms, but there is something less known, something you may not have heard. Olympus Mons may have once been an island in an ancient Martian ocean. How tall is Olympus Mons? When we measure mountains on Earth, we start from sea level. Using this criterion, the tallest volcanoes on our planet, such as Mauna Loa and Mauna Kea in Hawaii, reach an altitude of about 4,200 meters above sea level. However, if we consider their height from the ocean floor, meaning from the base of the volcanic structure, these giants would exceed 10 kilometers in height, a figure much closer to the 22 kilometers of Olympus Mons. But there's a fundamental difference to consider: gravity. Earth has about 3 times the gravity of Mars, meaning that raising such a massive volcanic structure requires much more energy here on Earth compared to Mars. But there's a problem. Mars has no sea level, so what do we use as a reference to measure the altitude of Olympus Mons? The 22 kilometers of Olympus Mons are measured relative to its northwestern base, the lowest point of the surrounding terrain. However, there's a more refined measurement method. Planets are not perfect spheres but oblate spheroids, slightly flattened at the poles and bulging at the equator. We can therefore measure the height of Olympus Mons relative to the theoretical shape of the planet itself. Using this method, the volcano's height is reduced to about 21 kilometers. Even more precise is the comparison with Mars' areoid, a concept analogous to Earth's geoid, representing the true shape of the planet. But in any case, Olympus Mons remains a colossal mountain, difficult to imagine in its real dimensions. Olympus Mons, a volcanic hotspot on Mars. Unlike Earth, Mars has experienced little tectonic activity. It is believed that Olympus Mons was formed by a hotspot, a hot point in the Martian mantle that pushed volcanic material through the crust, creating the massive volcano. Here on Earth, we have similar examples like Hawaii and the Canary Islands, where chains of volcanic islands have formed due to the movement of tectonic plates over a fixed hotspot. On Mars, however, Olympus Mons is a unique case. Unlike Earth's volcanic chains, tectonic movement has been almost non-existent, allowing this volcano to grow in a single spot for billions of years. This is why Olympus Mons has reached such extraordinary dimensions. Hawaiian volcanoes, in fact, are also shield volcanoes, just like Olympus Mons. These volcanoes have a much wider shape than they are tall, due to the low viscosity lava that gently spreads over kilometers before solidifying. Olympus Mons, with a diameter of about 600 kilometers and an altitude of 22 kilometers, is the largest example of a shield volcano in the solar system. It is often said that if we were to walk on its slopes, we wouldn't even notice we were going uphill, given the gentle 5% incline. The formation of Olympus Mons began about 3.7 billion years ago, and most of the volcanic structure we see today formed over the following 1.5 billion years. But there's more. Recent studies suggest that the volcano might still be active, with evidence of eruptions occurring as recently as 2 million years ago, a blink of an eye in geological terms. This means that Olympus Mons could still erupt, though sporadically and on a limited scale. Olympus Mons, an island in an ancient Martian ocean? One fascinating feature of Olympus Mons is its cliff, a sudden drop of about 6 kilometers at the base of the volcano. According to recent research published by a group of French scientists from the CNRS, this cliff could be the coastline of an ancient Martian ocean. It is now almost certain that Mars once harbored liquid water, at least until about 3 billion years ago, and Olympus Mons, which formed around 3.7 billion years ago, would have coexisted with this ocean during its growth. The Vastitas Borealis, a vast flat region around Mars' North Pole, has long been considered the possible seabed of an ancient ocean. And right at the edge of this region lies Olympus Mons. The 6-kilometer cliff at the base of the volcano has been interpreted as a shoreline, the point where the ocean met volcanic lava. If this hypothesis were correct, It would mean that the ancient Martian Ocean was incredibly deep, with much more water than previously estimated. However, it's possible that the formation of the Tharsis region, with its crustal bulge, altered the original coastline, raising it by several kilometers. An enigma yet to be solved. This study, though fascinating and innovative, is just a hypothesis based on morphological observations. To confirm or refute this theory, a more direct approach would be necessary, perhaps a mission that studies the sediments at the base of Olympus Mons. A mission to this gigantic volcano could reveal hidden secrets about Mars and its ancient oceanic past. Thanks for watching. Don't forget to subscribe to the channel and hit the bell icon to avoid missing any upcoming videos.